morning, everyone. So far in math, what's been happening is I've been giving you a method and you guys have solved a system using that method. But today, I'm not going to tell you which method to use. I just want you to solve the system. Now, does that mean you could use the same method over and over? Well, no, sorry, I am going to make you do at least one of each method. But once you've gotten that one, if you want to do the rest with elimination, go for it. If you want to do the rest with substitution, fine. And if you want to do the rest with graphing, sure, just make sure your lines are really neat. But what I want to do before I set you free on that is just point out a couple things to you when it comes to picking out which method is going to work best. Because while all of them work, some of them work a little bit easier given the type of problem. So let's start with graphing. What, for me, makes me want to graph? Well, very little, because quite frankly, it's my least favorite method. It's just not as accurate and it takes a lot of work, but some people really like it. And the easiest equations to graph, or the systems that work the best for graphing, are ones like this one here, where when you're given your system, it already looks almost like it's in slope-intercept form. Because slope-intercept form is very easy to graph. I can see I have my intercept of -3, I have a slope of 2, so I'd be going from -3 and then up and over 2 over 1, and that would be pretty easy. And then when I need to graph my second line, well, I still need to get into slope-intercept form, but that only requires getting rid of this negative. And I could just multiply both sides by -1 to get -2x plus 1. And that would mean I'd have an intercept of 1, positive 1, because again, this would be changed to a positive, and I'd be at a slope of -2, because this would have changed to negative, giving me 1, and then I'd drop to 1 over. And it'd be really easy to find this point of intersection of 1, -1. So when do you use graphing? Well, I recommend that you use graphing when they're already close to or in slope-intercept form. That's my first recommendation. Close to or in slope-intercept form. And by the way, the second worksheet that I sent you is the notes on this, that first column. You can ignore the other columns off to the side for now. We will talk about those in the upcoming days. But for now, just worry about that first column for recommendations. Okay, so let's look at this next one. If I'm looking at this one and I'm trying to figure out which method will work best to solve this, I really wouldn't think of graphing. Again, it's not in slope-intercept form, and that just means a lot of work for me. But I can still solve this using another system of equation solution technique, and the one I would use is actually substitution. And here's why. See how y is already almost by itself? Like all I'd have to do is add 2x to both sides to get y equals something. That means that I'm really close to substitution, because remember, all you need to substitute is have y equal to a number, or a number in a variable. So I would end up having here y equals a -2x plus 2, or I'm sorry, a positive 2x plus a -2. And that means I could substitute that into this equation for y, so I'd have 6x plus 2 times my 2x plus -2 is equal to 16, and that's something I could solve. So when do you use substitution? Well, substitution is easiest to use when you have one variable already by itself. And over here with number 3, what I would do is, again, substitution. I have one variable that's already pretty close to being by itself. So I'd have to move the 4x over and get rid of the negative, but that would go pretty quick and I'd be able to substitute it in. So that leads me to, what about elimination? When would I use elimination? Well, my favorite time to use elimination is when I see variables that already are opposites or close to opposites. So for instance, if I'm skimming through these and I see a number 8, that I have a positive 2y and a negative 2y, that tells me that what I want to use is elimination, because if I combine these two, that will disappear really fast. But I could also use elimination for problems like the one above. I know that x is already pretty close to being by itself, so it would not be hard to do substitution here. But I could also do elimination just by multiplying this whole equation by a -7. Why -7? Well, if I look at this x, Remember that I want the x's to have the same coefficient in front of them, or the y's to have the same coefficient, aside from being opposites, because that will make them easy to cancel out. So if I multiply this whole second equation by -7, there'd be a -7 in front of this x, and while these numbers would change, I'd still be able to combine the two equations easily, getting rid of the x's. So that one would be the second thing that would be easy to do with elimination. Now don't forget that while there's usually an easier method, all of the methods work. So let's say you took this one and you're like, I want a graph. Well, maybe that wouldn't be my first choice, but you could definitely graph these and get to -1, 3. Or you looked at this one or let's actually look at this one real quick and you're like, well, nothing really cancels easily. These numbers don't look very similar. I don't really want to do elimination. Or what about substitution? Well, substitution is going to be maybe a bit harder because I have to divide everything by a 3 when I'm solving for the y or the x. But it's doable. I could do substitution. Or maybe you looked at this one and said, well, I could graph this. Graphing will be easiest. That's fine. Any of those methods will work. Personally, I think the easiest way to solve this one is elimination, where I'd multiply the first equation by 4 and the second equation by 3, because then these two things in front would both be 12. One would be positive, one would be negative, and they'd cancel each other out. Because you can multiply more than one equation, that's totally fine. But we're going to stop there. I want you guys to try out the problems on the worksheet that I gave you. The instructions are in Classroom, but just to clarify, what I'm looking for is that you guys spend the next 2 days working on these, and then I'm going to give you guys another quiz because a couple of us need a little bit more practice with systems before we move on. And that's not a bad thing. Systems are pretty hard. And with these, make sure that you guys remember to submit a photo of your work from today so I can give you credit. Tomorrow, if you have questions, please drop in and ask them, and we'll get everything sorted out. I hope you guys have a wonderful day.